Hey everyone, in previous video we implemented Mypy type checks by prompting cursor agent. In this video we'll be using cursor rules to automate that process so we don't have to keep prompting agent to implement type checks after every response. This is my root project. Let us open cursor by using cursor space dot command. Now before we begin working with cursor rules, let us add some new models. So you can already see that cursor has come up with Composer 1, which is its first agentic coding model, and it's supposed to be faster than similar models in its weight class. Let us add some models which are not displayed here. So usually I always like to have Sonnet 4.5 non-reasoning variant. So in some cases where the task is simple enough, I don't want to spend time or energy on reasoning efforts, use the non-reasoning variant of that model. Then I can view all models. I have GPT-5, Haiku 4.5. So Haiku is basically smaller variant of Claude models. So there is Haiku 4.5, then there is obviously Sonnet 4.5, which is larger model than Haiku. And the largest model from Anthropic is Opus. So Opus 4.1 is the newest version of Anthropic's largest model. So we'll have both non-reasoning as well as reasoning variant of Opus. We can keep GPT-5 mini and GPT-5 nano just in case if we want to use it. And we'll have Haiku 4.5 non-reasoning variant also. Now the normal GPT-5 has by default medium reasoning effort, as you can see here. But if you want to fiddle with how much reasoning effort is spent by GPT-5, then you can also choose, for example, GPT-5 medium, which anyway GPT-5 by default is medium, but you can have GPT-5 high, which is a higher reasoning effort than GPT-5 default. And we can also have GPT-5 low, which is a lower reasoning effort. Usually I don't use the fast variants of these models because they'll be much more pricey. You can see the GPT-5 high fast will be twice the price of GPT-5 high because it will be giving you response faster, but I generally don't use them. You can select them if you want. Let me just parse through whether I have every model that I need for now. GPT-5 fast, medium, medium fast, high, GPT low, Haiku. So I have all the models. I'm not for now using open source models from DeepSeek. We'll add them later when we discuss about open source models and Hugging Face in general, okay? That's it for adding new models. Now let's start adding cursor rules and then we'll get into how they work. So you can add cursor rules by going to settings and then you can select rules, memories and commands. As you can see that we have user rules here, and these are the rules which are applied globally across different projects under your user profile. We already have a user rule here. Please reply in a concise style, avoid unnecessary repetition or filter language. The rules that we will be applying for most part will be under project rules. And these are the rules that will be scoped to the code base you're working with, to your local project. We can add a new rule by clicking on add rule and it will open command palette here. We can also get to that command palette directly by selecting Ctrl+Shift+P, and we can type new cursor rule and select file new cursor rule option. And this is where we can type the name of our rule. In this case, we are adding cursor rules. And the moment we do that, you'll be able to see a .cursor directory created under our root project and rules folder created under it, which is where our new cursor rules file got added. Now, a few things to remember. All the rules that are applied to our local project or project rules should always be created under .cursor rules directory. Cursor rules file will have this .mdc extension. Now .mdc extension is for all intents and purposes similar to .md or markdown extension. There are some differences between .mdc and .md, but for all intents and purposes, it works like a markdown file. So that's all you need to remember for now. Then we have this drop down, which will allow us to select how to apply cursor rules, whether we want to always apply that rule, in which case it will apply to all our prompts, whether we want to apply it intelligently. Now this means cursor agent will have to decide when to apply this rule, in which case our description of the rule will be very important because model will look at the description and decide whether for a given prompt or given user question it's necessary to implement or apply this rule. Then we have apply to specific files. For example, if we have a rule that we only want to apply to Python files, we can use a wildcard pattern.py to make sure that that is where it applies. And as you can see, it added this glob pattern to the application of this rule. We also have this option, apply manually. In this case, anytime we want this rule to apply, we'll have to pass that within our prompt. For example, please implement this. And then we give the context of cursor rules by using @ symbol, okay? In our case, we want this rule to always apply. So I'll be copy pasting a rule here Now this rule I got from an open source repository, which I went ahead and modified to work with my own use cases. And you are free to use this rule and modify it howsoever you see fit. Okay. What this rule does is essentially lay down very basic concrete guidelines for creating cursor rules. Because we'll be using a lot of help from cursor agent to create new rules, it's possible that the AI models we are using might not have enough context about how to create cursor rules and which location to create them under. So these rules just provide that along with other conventions about how to go about creating cursor rules. Okay, so now that we have created this cursor rules.mdc file, let's prompt cursor to create a rule for implementing Mypy type checks. Create a cursor rule for implementation of Mypy type checks in production grade Python projects, and we'll make sure it has context of our pyproject.toml configurations file, and we'll use Sonnet 4.5 for this. Yeah, let's go ahead and let it create it. Now our expectation is that it will look at, in fact, say it's reading cursor rules.mdc file. It will be inspired by this cursor rules.mdc file and will use whatever we have defined here to create a new cursor rule for Mypy type checks. And as you can see, it's already created rule file here. Okay, so let's click on it. Now, before we review this Mypy type checking rule file, let us understand what just happened. So we have this cursor rules.mdc file, which is supposed to always apply. What it means is that anytime we send a prompt to cursor agent, in this case, we are sending this prompt asking cursor agent to create a Mypy type checking rule. The cursor rules that we have defined here will provide system level instructions to cursor agent. So it's not just our prompt, but also the contents of these rules, which will be sent to the AI model as part of its overall model context. And this is Cursor's way of implementing state. Okay. We've already discussed state management at a high level in one of our previous videos, where whenever you're designing an AI application, there are three components that are especially important. The first one is the model itself. Obviously, the more powerful the model, the better the response will be. For example, on average, GPT-5 will be better than GPT-4, which will be better than GPT-3, and so on and so forth. Second is the user prompt itself. So it's garbage in, garbage out. The better the user question or prompt is, the better response will be, all things being equal. Okay. And then third aspect is context management or state management, or how you persist information between different API calls. And this is where you have to remember that AI models by themselves don't have any memory. They don't have any inherent state. And therefore, if you make an API call and then if you make another API call asking something else, the information or memory doesn't persist between different API calls. And this is where any functioning AI application has to have a strategy and design for managing this context or managing how to persist information across different API calls or different conversations. And cursor rules is one of the ways in which cursor agent ensures that certain information persists between different conversations so that we don't have to keep including that in our explicit prompt. Okay, so in this case, for example, we want cursor to create cursor rules, but we also want it to always remember how to create cursor rules without having to explicitly prompt it. Okay, you can also confirm that cursor rules.mdc is one of the active rules being considered by cursor agent in overall model context by hovering over this ring or circle next to @ symbol, and you can see cursor rules under active rules. And you can also refer to the chain of thought of the cursor agent to confirm that it has indeed explored and read cursor rules.mdc in order to create this Mypy type checking rule. So now let's go ahead and review the MDC file that was created. You can see that it has decided to apply this rule only to specific files, which is .py, which kind of makes sense because we won't be implementing type checks for non.py files. In either case, I would rather this being always applied. So I'll keep always apply to be true. I could have also chosen apply intelligently, in which case the agent will decide when to apply it, or apply manually, in which case I can give it context within prompt itself using @ symbol. But always apply makes sense in this case. Then you have Mypy type checking, production grade application, then guidelines for implementing strict production grade type checking. Then we have configuration reference to pyproject.toml file, place Mypy configuration in the tool.mypy section with this essential settings. So not sure why this has been included, because I think pretty much all of the settings are already there in our configuration file. So let's have that by the side. You can already see, right? Strict true, and then one unused configs true, redundant cast true. Just as an aside, the point of this particular setting where we have incremental true and our cache directory is .mypy cache, which you can already see here, is that every time you make a change in your code, if you have a giant code base, you don't want Mypy to type check entire code base after every change, because that will be very slow, and Mypy in general is a slower tool. What this incremental true does in combination with this cache directory is that anytime you make local change in your code base, it's only that change which is type checked and not the rest of the code base. So it's faster than what it would be otherwise. And it uses this cache directory to maintain snapshots of successive incremental type checks. Okay. Now these two settings are basically telling Mypy to not type check OpenAI and .env libraries. So I mean, this seems redundant, so let us get rid of this, what is essentially just the pyproject.toml configuration, which we already have. Instead, we'll just make it more concrete. So you can give any file reference within your cursor rule file using this @ symbol. So we'll link it to that toml configuration file in case if it's not able to find it. We don't need to have the entire configurations listed in our cursor rule file. Then we have code style guidelines. So this is where our function doesn't have any return type annotation, and this is a good example of that. So it seems like there are different good and bad examples, which is what we had already indicated in our cursor rules file. So it's basically learning from that and implementing that while creating this new rule file. Okay, so this is an example of implementing data classes instead of creating conventional classes where we have this init dunder method. Then we have typed aliases, and then this is one of the things which I was especially looking for, is that it should avoid any as a data type because it's too loose or too broad. Okay, so that's good. I mean, these are all PowerShell commands too. So I will also make sure that can also run this on PowerShell. Then it has some guidelines for pre-commit hook, which we have not yet created a pre-commit YAML. We'll create it down the line, but for now this is not required. So maybe we'll just get rid of it. The same thing with this, right? Because we have not yet dived into CI/CD pipelines. So we'll get rid of this. Troubleshooting common issues. So this is a problem. It's assuming that it's a pip project instead of UV. Maybe we should create a UV cursor rule also so that it doesn't assume that it has to pip install stuff. Okay, you should remember, instead of pip installing, what we want is UV adding. Third-party library issues, it's fine. Gradual type adoption, ignore comments. And then we have best practices. Always annotate public APIs. Use modern syntax. So we already discussed this in our last video that in recent versions of Python, we use small case L instead of uppercase L for typing lists, and similar changes. For example, for dict, where we use small case D instead of uppercase D in order to type dictionaries. Avoid using any. This is extremely important because in the last video, we saw that in the response which Cursor AI gave us, it used any to type our API params, which is loose. So in cases like that, we wanted to use type where, protocol, or union. Instead of union, I actually like to use pipe, which suggests the same thing. So these are advanced typing operations, but we want Cursor agent to be using this rather than using any. We can also make this more concrete that if for some reason it's unavoidable to use any, then narrow it as much as possible and leave a to-do or a short comment explaining why. Document type ignores, always add a comment explaining why. I think same thing we can include here also. The expectation is that Cursor agent will have a to-do or a comment explaining why it decided to ignore some types. Run Mypy in CI. This is not yet very relevant, but we'll still include it. The idea is that in our CI or continuous integration pipelines, Cursor agent should always run Mypy type checks to make sure that bugs are caught early before reaching production in our CD or continuous deployment pipeline, which follows CI pipeline. Incremental adoption. Then we have type stubs for external libraries. We can actually make this more concrete. So what can say for external or untyped libraries? Propose either installing stub packages or adding targeted overrides. We've already in fact added it in our pyproject.toml file. So if you check out this, okay, these are overrides for our external libraries OpenAI and .env. So we have chosen that option instead of installing type stubs for these respective libraries. So we can include that also. Should only ignore the modules which we have included in our overrides in our configuration file. Okay. I want to include one more point because even though we have already explained it to not use any as far as possible, I want to make it more specific because it will come up a lot, especially when we are data typing dictionary or similarly nested data structure. So what I want to add in this rule file is for some data structures like dictionaries, we want it to consider typedict, data class, or pydantic models. Now we have not yet discussed pydantic models. We'll have a detailed video on it down the line, but think of it as one of the ways that we can type or validate dictionaries during runtime. So it's somewhat different than typedict or data classes or other ways of type checking during our static code analysis step or during our CI step, but it makes sure that whatever data structure we are dealing with has a certain type with it, and if not, then it fails that validation. Okay, so we want it to use this instead of using loose dictionaries. Okay, then we have this VS Code settings for enabling Mypy, and we also have PyCharm settings, which I don't think it's necessary. So this looks good. Now let us select keep all to keep all these changes. So there is one more rule which we need to create, and that is about UV package management. So far, Cursor agent doesn't know that this is a UV project primarily. So oftentimes when it tries to implement something, it will run pip install or other pip commands, which we don't want it to do. So we'll add another rule here using this new file option, and we'll name it uv-package-management.mdc. And we also want this to always apply, so we'll keep this true. Now there is a website which houses a lot of cursor rules, and you can visit that by typing cursor.directory. And then you can go to rules, and this is where you'll find rules for different programming languages and tools. So as you can see, for Python, there are rules for different contexts. For example, in this case, it's for a persona of a data analyst. And then we have one for deep learning, for web applications, RESTful APIs, etc. Okay, so you can explore this, and there are a lot of rules here you can take from here, and you can add your own modifications, which is what we'll be doing for UV. So if you type UV cursor rules here, this is what you will get. It is a good starting point. So I took this rule from here and then added some of my own modifications, which is what I'll be copy pasting here. Okay, and as we already discussed, .mdc file for all intents and purposes is a markdown file. So we can preview this like a markdown file. So if we click on preview on the upper right corner here, it will open a preview to the side. This is our UV package management rules. So now, because this also will be included in our overall model context, Cursor agent will always be aware that this is a UV only project. So it should avoid using pip or poetry or conda or such other package management tools. Okay. And this also is a good one, because if you have watched my UV video already, you will know that uv.log file should never be modified manually. It should be managed by UV and not by us. Okay. And this is how we add packages. This is how we remove packages. This is a sync command. And this is our CI or continuous integration workflow, where we are calling Mypy tool by running uvx mypy command. Okay, so now that we are done adding those 3 rules, that's it for this video. In next video, we'll be using these rules to implement Mypy type checks.